In 1893, George Ferris engineered the Ferris wheel. It was 250 feet in diameter. If the wheel makes one revolution every 40 seconds, then the function h of t equals 125 sine of 0.157 t minus pi over 2 plus 125 represents the height above the ground in feet of a seat on the wheel as a function of time t, where t is measured in seconds. The rise begins when t equals 0. During the first 40 seconds, at what time t is an individual on the Ferris wheel exactly 125 feet above the ground. We are given this function where h represents the height above the ground. The question asks us to find the time when the individual, the person sitting on the Ferris wheel, is exactly 120 feet above the ground. So h equals 125, and we're looking for t. Notice that this equation is actually h of t equals 125 sine of 2 pi over 40 t minus pi over 2 plus 125. 2 pi over 40 because the principal period of sine is 2 pi, and in this case, the period is 40 seconds. This is omega, 2 pi over the period. We then set this equation equal to 125. 125 equals 125 sine of 2 pi over 40 minus pi over 2 plus 125, and we isolate t. We subtract 125 from both sides of the equation to obtain 0 equals 125 sine of 2 pi over 40 t minus pi over 2. And then we divide it by 125 from both sides of the equation to get 0 equals sine of 2 pi over 40 t minus pi over 2. Within one rotation, sine of theta, where theta is the argument 2 pi over 40 t minus pi over 2, sine of theta is 0 only when theta equals to 0 or when theta equals pi. Remember that we're looking for t here, not theta. Theta is 2 pi over 40 t minus pi over 2, and the angle is 0. We isolate t by taking 2 pi t over 40 equals positive pi over 2. So t is pi over 2 over 2 pi over 40, and this will give us 10. This is pi over 2 times 40 over 2 pi. So this is 40 over 4, which is 10 seconds. There is another time where this person reaches 125 because it is the Ferris wheel. If this is after 10 seconds and the wheel rotates 40 seconds, then the time has to be 30 seconds. But let's see. 2 pi over 40t minus pi over 2 equals pi, which is another solution here. First, we isolate 2 pi over 40t. 2 pi over 40t is pi plus pi over 2. So this is 2 pi over 40t equals 3 pi over 2. Pi plus pi over 2 is 3 pi over 2. T equals 3 pi over 2 over 2 pi over 40, which is 3 pi over 2 times 40 over 2 pi. And this is 120 over 40, so this is 30. So yes, this is 30 seconds after. Remember, if we assume that we start at times 0, and it makes one rotation every 40 seconds, after 10 seconds, 20 seconds, 30 seconds, and 40 seconds. So for part A, what time t is an individual exactly 125 feet above the ground after 10 seconds and 30 seconds after. For part B, during the first 80 seconds, what time t is an individual exactly 250 feet above the ground. We either set the equation 125 sine of 2 pi over 40t minus pi over 2 plus 125 equal to 250 and solve for t. Or we see that when t equals 0, we are at the bottom. When t equals 10 seconds, we are at 1/4 of a quarter. When t equals 20, we are at the top. And at the top, the height is 250. So during the first 40 seconds, the individual is exactly 250 feet above the ground when t equals 20. During the first 80 seconds, so after 40 seconds, we will go around another rotation, 80 seconds total in 2 rotations. This is where t equals 0 or 40 seconds, 50 seconds, 60 seconds. So during the first 80 seconds, the individual is exactly 250 feet above the ground when t equals 20 during the first rotation, or when t equals 60 seconds during the second rotation. For part C, during what time interval? Not just the time, but the time interval during the first 40 seconds of the ride is the individual more than 125 feet above the ground. One way to do this is to set the height, the equation, 125 sine of 2 pi over 40t minus pi over 2 plus 125 greater than or equal to 125 and solve for t. But we can just simply look at this Ferris wheel here. The person is above 125 feet from t equals 10 to t equals 30. The interval we're looking for is 10, 30, and it is an open interval.